Water can cleave sucrose, which is a disaccharide, in the presence of acid into two monosaccharides, glucose and fructose. Now you were given concentrations in this problem and were asked to figure out how long it's going to take. This requires an integrated rate law. And we went over 3 of them. We went over one for zero order, one for first order, one for second order. And when you need an integrated rate law, you have to get the right one. You can't just use dimensional analysis to figure this out. It won't work. This is a first order reaction. So this is a natural log relationship. And that's why you can't just use dimensional analysis to get this to work out, because it's got a natural log relationship in it. Okay, now when you're done, you are going to use dimensional analysis to make sure your units work. But this is not simply a conversion where you go from inches to centimeters. It's much more complicated than that. What about the temperature? What does that have to do with anything? The only thing temperature has to do with this problem is you change the temperature, you change the rate constant. The T in the mathematical formula, that is not temperature, it's time. Lowercase t usually means time. Well, now we need to pull all the information out so we can set the problem up. So we'll grab the initial concentration. We'll grab the final concentration. We need the rate constant. I'm not worried yet that it's minus K. We'll worry about that in a bit. Now in the body of the problem, the units are given as seconds to the minus 1. It's just reciprocal seconds. And watch the time units that we want. We're asking in hours. All right, make some room. We need to rearrange that mathematical formula for time. All right, so it's minus kt. So we'll move that to the left side. So we get time on the left. We still have the natural log of the initial concentration on the right. We subtract the natural log of the final concentration from both sides, so that's why it's minus that. And then we have to divide by k. Now we'll plug in. So we need the natural log of the initial concentration. We need the natural log of the final concentration. And we'll subtract that. This is a style choice, what I'm doing here. You're dividing by k, but I'm going to keep this part separate. Again, it's a style choice on my part. And that's because k has units of reciprocal time in it, and we're dividing by k. So sometimes, for some people, that can get a little iffy as far as how you set it up. So I'm thinking about this as 0.00016 over seconds. And since I'm dividing by k, you're multiplying by the reciprocal, and that gets me seconds in the numerator. Now, this is what I was saying, is even though you can't just use dimensional analysis to plow your way through this, you have to have the mathematical formula. You're going to use dimensional analysis to make sure it's set up right. See, we want time units when we're done. We have time units in the numerator. Good. What time units do we want? Okay, we need hours. So I need to convert seconds to hours. And I'm just going to do it in one jump. Be careful on that. If you need to, go seconds to minutes to hours. A very common mistake is to go 60 seconds in an hour. Don't do that. Units check, good. When you do the arithmetic on this, be careful on the left there with the natural logs, because You do need to know how to use natural log in your calculator. If you don't know, get help on that. And it's natural log of 0.1 minus the natural log of 0.01, and then all of that divided by the rest of it. So you got to watch your order of operations. And no negative time here. Only positive time. If you have negative time, you put something in wrong. You probably swapped your concentrations.